Okay, section 3.6, chain rule. So the chain rule is the most widely used differentiation rule in mathematics. The chain rule is used to find the derivative of a composite function. Okay, so a composite function is a function within a function. Okay, so it means I have a function, and within that function I have another function. So if y equals f of u, okay, so u would be one function, and f would be another function. Then the derivative of f of u, do not laugh at the letter choice here, would be f prime of u times the derivative of u. Okay, so there are some tutorials on calculushelp.com if you want more practice, but there's also a lot of practice within this packet. So chain rule can go by a couple of names, the first being the outside-inside rule. So you want to differentiate the outside function of f and leave the inside function alone, and then you want to multiply that by the derivative of the inside function. Okay, another way to remember chain rule is the mama-baby rule. So you want to find the derivative of the mama, which is the outside function, and then the derivative of the baby, which is the inside function. So in the first example, we have y equals sine of x squared plus x. So the outside function is my sine function, and my inside function is my x squared plus x function. So we'll take the derivative of the outside, which was sine, and we'll leave the baby alone, and then we'll multiply that by the derivative of the baby. Okay, so we're going to do a few examples together, and I'm going to leave a few examples for you all to do on your own as extra practice. So for this example, y equals 5x squared minus 2x, all raised to the fourth power. My outside function is the fact that everything's raised to the fourth power. My inside function is the 5x squared minus 2x. Okay, so to find the derivative, I want to find the derivative of my outside function, right? So I'll have y prime is equal to the derivative of something raised to the fourth, means I bring the 4 down, keep the baby inside, and then subtract 4 by 1, which gives me 3. And then the derivative of the baby is what we're going to multiply by. So this was the mama, and this is the baby. So the derivative of the baby is equal to 2 times 5, which brings me 10x minus 2. And this is 4 times 5x squared minus 2x to the third. So there's our final derivative of y. The derivative of the mama, when we brought down the 4 and subtracted by 1, and the derivative of the baby, which was the 5x squared minus 2x derivative. We're going to do a few more examples, and then I'm going to leave a few for you all to work on if you want extra practice. So number 3 is an example that I'm going to leave for you all to work on if you would like extra practice, because number 3 is very similar to the example that we just did. Right, we have the mama function, which has to do with that negative 2 and the 7, and then the baby function, which is the 2x to 2t cubed minus 3. This focus thing is really annoying. Okay. Number 4 is also a derivative situation similar to 2 and 3. The only difference is that our baby requires quotient rule. So the derivative of the mama, bring down the 5, keep the baby, and then subtract by 1. And then we're going to multiply that by the derivative of 3x minus 1 over x squared plus 3. So for this, we would have to use quotient rule. So we would need u and v and ho d high minus high d ho all over ho ho would need to be used to find that derivative of the baby. Okay. For the next one, number 5, the mama function is sine, and the baby function is 2x. So our mama, the derivative of sine is cosine. We'll keep the baby, and then the derivative of the baby is 2. So we have 2 times cosine 2x. Okay, for number 6, our mama function is 5. Our baby function is tangent of x. So you can use that to help you do number 6. And number 7. In number 7, we have 2 babies. So we have a mama and a baby. So let's do that part first. So y prime will be, bring down the 3, sine, keep the baby, and squared. And then we're going to take the derivative of the baby, which is sine of 4x. And what you notice there is that we have a mama of sine and a baby of 4x. So we have 3. I'm just going to rewrite this as sine squared 4x. And then we want the derivative of this mama. So that's cosine, keep the baby, and then the derivative of 4x is 4. So we'll have 3 sine squared 4x cosine 4x times 4. So 3 sine squared 4x cosine 4x all times 4. And since this is all multiplication, I can multiply the 4 and the 3. So I have 12 sine squared 4x cosine 4x. And similarly, for number 8, we have a baby within a baby. Right? So we have the 5 is my mama, the secant 3x is my baby. So y prime would be 5 secant 3x to the 4th, and then the derivative of secant 3x and within that we have another baby. So we have 5, I'll rewrite this as secant 4 3x we'll take the derivative of secant, which is secant, keep the baby, tan, keep the baby, and then derivative of 3x, which is 3, so we have 5, secant for 3x, secant 3x, tan 3x, all times 3. And then we can simplify. So we'll do 5 times 3, which gives me 15. Secant times secant, so secant to the 4th times secant gives me secant to the 5th. And then tangent. And there is our derivative for that. Okay, so now let's look at what about when we are given a table of values and we want to find the derivative using chain rule. So function f and g and the derivatives are given the following values: x equals 2 and x equals 5 are also given for those functions and the derivatives. So we want to find the derivative of f of g of x at x equals 2. So what we need is to figure out what's the mama and what's the baby. So we know that f is our outside, so f is the mama and g of x is the baby. So to use chain rule, we would need f prime of the baby times the baby prime. So if we're looking for when x equals 2, we'll substitute in the 2. So y prime of 2 should be f prime of g of 2 times g prime of 2. So g of 2 is 5. So we have f prime of 5 times g of 2, g prime of 2, which is 8. So f prime of 5 is 10, and we're going to multiply that by 8. So our answer is 80. Now, looking for g of f of x. In this case, g is our mama, and f of x is our baby. So we want y prime to equal the derivative of the mama with the baby times the derivative of the baby. And since we want to find this at the value of 2, we have g prime of f of 2 times f prime of 2. F of 2 is 5, so g prime of 5 times f prime of 2, which is negative 6. G prime of 5 is 4 times negative 6 gives us negative 24. You have a few of these problems in your problem set as well, so you can definitely use that to practice. The last piece of the notes deals with parametric equations. So parametric equations are equations in which the y value and the x value are represented by equations. So to find y, there's an equation. To find x, there's an equation. Okay, so what we're going to do is use chain rule to help us to figure out how to find the derivatives of those types of equations. So if y is equal to f of x, okay, so notice that we're talking about x here, so it's in terms of x. And if x is equal to f of t, so this is in terms of t, then the derivative of y in terms of t is equal to the derivative of y in terms of x times the derivative of x in terms of t. So we're going to do an example together to help us understand a little bit more of what that means. So for this example, we want to find dy dt if y is equal to 4x squared plus 2 and x is equal to t cubed minus 1. And we want to express our answer in terms of t. So at the end of this, we want our derivative to be only in terms of t. Okay, so we know that dy dt is equal to dy dx times dx dt. Okay, so what that means is the derivative of my y function, which in this case is 4x squared plus 2, times the derivative of my x function, which is t cubed minus 1. So when we take the derivative of my y function, we have, bring down the 2, so that's 8x, and the derivative of 2 is 0. And then on this side, derivative of our x function, bring down the 3. So we have 3t squared. And the derivative of 1 is 0. Okay, so we want our final answer to be in terms of t only. So right now, we have that dy dt is 8x times 3t squared. So we have to put x in terms of t. So from our problem, we know that x is equal to t cubed minus 1. So we're going to use that to substitute into our answer. So we have 8 times t cubed minus 1 times 3t squared. So when we multiply that, we get 8t cubed minus 8 times 3t squared. So our final answer is 24t to the 5th minus 24t squared. And that would be the derivative of y in terms of t. So let's look at now what happens if we have our x and our y functions already in terms of t, and we want dy dx. So if both functions are already in terms of t, Then to find dy dx, dy is the derivative of y, dx is the derivative of x. So we're going to use that to find this equation of the tangent for a curve that is defined parametrically. So for this example, I've broken down the steps on how to write the equation of the line tangent to the curve when we have a function defined parametrically. So the first step would be to find the point of tangency. The second step is to find the slope of that tangent. And then the third step is to write our final equation of the tangent. So first thing we want to do is find the point of tangency. And our example problem is a curve is defined parametrically by x equals secant of t and y equals tangent of t. So both of these are in terms of t. So we'll use dy dx with the derivative of y over the derivative of x. Okay, so our interval is from negative pi over 2 to pi over 2. And we want to write the equation of the line tangent to the curve when t is equal to pi over 4. So our first step is to find the point of tangency. So we know t is pi over 4. So to find the point of tangency, we need x and we need y. So if t is equal to pi over 4, we're going to substitute that into my x equation and my y equation to find x and y. So t is pi over 4. So x is going to be equal to secant of pi over 4. And y is going to be equal to tangent of pi over 4. So x is equal to one over cosine pi over 4, which is equal to 1 over root 2 over 2, which reduces to square root of 2. And y, the tangent of pi over 4, is 1. So my point of tangency is x, which is square root of 2, and y, which is 1. Okay. So the next is to find the slope of the tangent. So we know the slope is the derivative, and to find the derivative from the rule above, we know that that's going to be dy dx, which means the derivative of y, which is tangent of t, over the derivative of x, which is secant of t. So the tangent of t is secant squared, so we have secant squared of t over the derivative of secant is secant tangent. And we can simplify that. So 2 secants up top cancel with 1 secant down at the bottom. So we get secant of t over tangent of t. And we're going to use that now to find the slope. And we want the slope at t equals pi over 4. So we're going to substitute pi over 4 for t. So we get secant of pi over 4 over tangent of pi over 4. And from the point of tangency, we know that the secant of pi over 4 was square root of 2. And the tangent of pi over 4 is 1. So our slope is going to be root 2. So the slope of the tangent is square root of 2. So we have our point, we have our slope. Last step is to write the equation. So we know we need it in y minus y1 equals mx minus x1 form. So y minus y, which is 1, equals the slope, which was root 2, times x minus x1, which was root 2. And there is the equation of that tangent. So, since I do not see you all until Thursday, I highly suggest getting started on the section 3.6 of the problem set, doing the problems you feel comfortable doing, especially using chain rule and the parametric and looking at tables and graphs. Thursday in class, I'll go over whatever questions you have, and you will have time in class to work on your problem set and study for Friday's quiz.